point has improved significantly, but for the last couple of years, I do everything myself, self-sufficient, which is good. So I am not too good yet in drawing a two-dimension, two arrows, both sides. But basically, that arrow, each arrow should have gone different ways. But I prefer this because it is true that the political and governance system drives this. With that as a framework, when we talk about climate impacts, ecosystem changes, what are the implications and what should adaptation be? I take the role of this panel, say role of science in adaptive development. I understand the organizers always wants to keep these thematic titles nice and short and punchy, but inside it there are a number of things we need to elaborate. Then it says develop a coherent and supportive policy in this panel. Let's look at the word science. It's not only the natural science, it's not only the physical, but the social and political science. And that itself is not enough. We need knowledge, the experience. And knowledge, we must not forget traditional knowledge, particularly when we talk about adaptation, adapting to changes. In this region, we have thousands of years, millennium of knowledge. Having the data, having the knowledge is good, but we need the wisdom. When to use this knowledge, when not to use it, when to use it here, when to use it there. We need knowledge and we need wisdom. Development, you hear about all types of development, sustainable development, eco-development, and we talk about preventive to preventive, sustained development. Here we talk about additive development. We hear about resilient development. All these are good. But surely we must also, these are okay, but we must also have forms of development that prevents the problem from happening in the first place. And if it happens, then we adapt to it. But better still is to prevent it. And with this, hopefully, the science that applies to the development, it becomes more enlightened. And my favorite word now, it's got to be transformational, a game changer, more than business as usual. So some emerging concerns and the imperative need for prevention and adaptation. All of us can spend a lot of time in talking about this. Let me just present one issue to you where we do not have enough science as we know it, the natural, the physical, the social, political science. And now I'm saying that we're not looking at one discipline or one sector. It's the atmosphere, hydrosphere, the lithosphere, the air, the water, the soil, everything on the soil system. Where these interact is the coastal zones, where 60-odd% of the world's population are now living, working, surviving, and projected to increase 2025 to 80%, from 80 kilometers, 80. One of the richest ecological systems, the coastal zones. Three things that are happening. When we talk about climate change, we all talk about global warming, winners and losers. Certain countries become warmer, it's great. You don't have to go to other countries to get a suntan. Then we talk about sea level rise. These are the focus. Global warming, sea level rise. Fine, we need to adapt to that. But looming are one of the cluster of one of the many, many issues. Oceans, land, water interface, the coastal zone. Acidification. Every time we talk about acidification, we think it's only SOX or NOx. But no. As I said yesterday to another group, there is a 600-pound gorilla in the room. And that is the carbon dioxide. An amount of it. And that is acidifying it. The pH, last week, the National Academy of Sciences in the United States put out a report. From the Industrial Revolution till now, the pH has decreased from 8.2 to 8.1. In that type of a pH scale, is hell of a lot. We are talking about a 1 degree increase in temperature, but now look at it, the decrease in the pH. And it's expected to decrease more Dissolved oxygen, nobody talk about that. There are dead zones, 400 coastal dead zones in the world. Then alien invasive species. Through atmospheric transportation and travel, ballast water discharge. We have got major gaps in science in this area. So, in my last chart, just looking at oceans, tremendous monumental changes are taking place in the chemistry, the physics, the biodiversity. Going to affect marine organisms, mangroves, coral reefs, functioning of estuaries, wetlands, etc. Major implications on socio-economic development, food, human health, human security, the whole of the human system. So when we talk about adaptation using science, we need to keep this framework in mind. Thank you very much.
Thank you, Professor Toon. Ladies and gentlemen, I would like now to invite Professor Jean Polotikov, Director for National Climate Change Adaptation Research Facility at Griffith University in Australia. Professor Politokov's research interests focus on climate change impacts and adaptation, and also the application of climate data to economic and planning issues. She specializes in the study of changes in extreme events. Professor Polotikov previously managed the production of the Intergovernmental Panel on Climate Change Force Assessment Report for Working Group 2, while based at the UK Met Office. She was also a lead author for Working Group 2 of the IPCC second and third assessment reports. And before joining the Met Office, she was a professor in the School of Environmental Sciences and also director of the Climate Research Unit at the University of East Anglia, UK. Professor Polotikov has authored more than 200 papers, articles, and reports on the topic of climate change and climate variability. Her proudest moment to date was attending, ladies and gentlemen, the ceremony in 2007, in which the IPCC was awarded the Nobel Peace Prize. Professor Polotikov, you are very welcome. The floor is yours.
Thank you. That's probably a bit longer than my presentation. So, I mean, the important thing about that is that I direct something called the National Climate Change Adaptation Research Facility. And the role of that organisation within Australia is to deliver to end users and decision makers, that is, the knowledge that they need to adapt to climate change. So we sit in a rather uncomfortable place between science and policy. We are neither scientists nor policymakers, but our job is to transfer knowledge between the two communities. And having done that for a couple of years, I do have a few thoughts around the role of science in adaptive development, the adaptation that I'd like to share with you today, although sometimes they're not particularly popular views, especially perhaps in this community here. So I guess then the first thing is to think what it is that we mean by science. And from the point of view, science is many things, but from the point of view of this discussion in these brief 5 minutes, I'm going to think a little bit about what is, generally speaking, the content of the IPCC Working Group 1 reports, which is around the physical science, particularly scenarios of future climate change and the type of regional scenarios that you might hope to use for thinking about adaptation. So one of the things that strikes me after a couple of years of working in the facility is that the role of science within the community of climate change adaptation is not always a benign one. That scientists sometimes are not always working with people within the adaptation community for the most pure of motives. Sometimes you find that adaptation is used as a justification for very large expenditure on, for example, climate models. And you also find that scientists are carrying out model experiments, climate model experiments, to explore future climate change without properly thinking around what it is that decision makers need in order to properly make the decisions that we need around climate change adaptation. So what you find is that scientists sometimes are generating knowledge which for end users is not appropriate. And it may not be appropriate because it's not in a form that they can understand, because it's sometimes unhelpful, being presented in the form of ranges of change or uncertainties, or it's not tailored to their needs or communicated in an effective form. So these are the kinds of things that scientists are good at. They're good at generating climate change scenarios of the change in the mean of a variable, mean temperature, mean rainfall. They're good at characterizing uncertainty. They're good at modeling temperature change with some degree of certainty and accuracy. They're good at regional, hemispheric, global changes, and they're good at changes in the very long term. But if you think what it is that the end users really need, that isn't the same thing at all. So whereas scientists are good at generating mean scenarios, what end users really need to know about is what's going to happen to extremes, because those have the biggest impact, and they are the events for which adaptation is most required. They hope for certainty, and whether or not that can ever be delivered is perhaps a subject of tomorrow's theme, so we'll readdress this tomorrow. They need to know about rainfall. That's a point that's been made already a couple of times in this meeting. It's all about water. They need to know about local changes, and they need to know about change on decadal scales. So there's a disconnect between what the scientists are able to deliver and what it is that the end users need. If we think about the form in which the delivery of information should be provided, then also you can come up with some interesting differences between what scientists like to deliver and what it is that end users really need. So this is an evaluation at the regional scale of temperature change over Europe from a project which looked at the differences in projections of future climate in a whole bunch of different models, and produced a range of scenarios that look like this, with some very significant differences in different parts of Europe, and it's really not information that decision makers can use. This presentation of data, so it's all about the ways in which you present the data. This presentation of data arises from something called the United Kingdom Climate Impacts Programme, and it took many, many years for scientists to come up with this method of presentation for end users. I wouldn't say that it's really hitting the mark exactly, but it's coming a whole lot closer. It's an attempt to generate information in the form of probabilities. So in the middle graph you see the probability of a change in rainfall by 2020, and on the right and left hand sides you see the 10% and 90% ranges. And generally speaking, decision makers find information presented in this form easier to deal with. What's interesting, I think, about this case is that this project took of the order of 6 to 7 years to really think about around the problem of how to present information from climate models to decision makers in a form that they would find useful. So just to summarize a little bit then, what can we say about adaptation and science? Well, adaptation is essentially a bottom-up process, and for scientists then, it's an uncomfortable place to be, because I'm a scientist and I know what it's like. You like to feel you're in charge. But in the area of adaptation, that cannot be the case. Scientists are not in charge. It's essentially science as a servant